My name is Samuel Hall, and today I'm going to be going over the best lightweight material for airplanes. So, to start off with, what exactly are we looking for? So, the material that we choose first must have a high elasticity and be relatively stiff, due to the amount of bowing that will occur while flying. Next, it must have a low density in order to keep it lightweight. And in addition to that, it must be able to perform under a wide range of temperatures due to the aircrafts going anywhere and everywhere. And finally, it must have a reasonable cost. Now, with these requirements, what would be the answer? Well, let me tell you. It would be the aluminum alloy 2024 T3. Why? Although it gets outperformed by materials such as carbon fiber, its cost effectiveness outclasses the majority of materials, making this the best choice. Now, even though it gets outperformed by other materials, it doesn't fall too short. It has high specific strength and is relatively stiff while being ductile as well. In addition to this, it can be manufactured quite easily and is very reliable, and it is commonly seen as the material of choice for wing and fuselage skins. Now, you can find where the wing and fuselage skins will be in this first diagram, and in our second diagram, you can see the stress and strain relationship of this material. So you can see that it is very elastic, tough, and yeah, it's a very good material. So comparing it to other materials, as I said, it gets outclassed in certain aspects. Now, titanium and high-strength steel are the two other alloys that are also used in planes. Now, titanium alloys would be used in the place of aluminum if not for titanium alloys' poor manufacturability and high cost. And high-strength steel's downsides consist of high density and a high susceptibility to corrosion and embrittlement, making this aluminum alloy the best choice overall in an aircraft. Now, how is it made? Aluminum 2024 is an alloy primarily made up of aluminum, copper, and magnesium. Aluminum makes up 90% of the alloy's total, structure. Copper makes up about 8% and magnesium around 1.5. The other elements would be manganese, which makes up about, I'd like to say 0.5%, and then there's a couple other elements in there as well. Now, to achieve 2024 T3, the aluminum is first heat treated, then strain hardened, and then naturally aged. And this process greatly increases its overall performance and its temperature resistance. Once this process is completed, it is then formed into sheets and bolted onto the aircraft. It is not welded because the material has a very low compatibility for welding. Now, in terms of its failure analysis, aluminum 2024 T3 under simplified gust loads has a life cycle of about 100 flight cycles. The most common type of failure that occurs in this material is corrosion failure. This is due to the low corrosion resistance of this material. However, this drawback is counteracted by coating the alloy with another aluminum alloy or aluminum 1ZN. Thank you for your time. That has been my project, and this is my reference table. Thank you all for listening. Goodbye.